Okay, so these are notes 5, 10. This is day 2 for our sum and difference identities. For the first one, it was find the exact value of sine of 285 degrees. I would have picked 225 plus 60. Just be careful, 225 is in that third quadrant, so everything for this identity, sine and cosine, are negative. The first quadrant, 60, they're both positive. Just kind of plug and chug your values in. You should get negative radical 2 minus radical 6 all over 4. Number 2, a function with this property, is a different way of looking at the sum and difference for tangent. Okay. These are kind of, they look super tricky, but really they aren't too terrible. What that's asking you to do is kind of what we did with some trig proofs, but these are much, much easier. Once you just take the left-hand side and turn it into the right-hand side. This is an example of the sum and difference identity for sine. This is your x. This is your y, so we're going to focus on this guy right here, and I'm going to change that into sine of x cosine of pi plus cosine of x sine of pi. From there, you're going to find the values for the ones that have pi in them, because you know that from the unit circle. Cosine of pi is negative 1, so this is sine of x times negative 1 plus, keep your cosine of x and sine of pi is 0. That goes away, and you just proved it. Same with this, with example B. For example B, they are asking you to prove the left matches the right. So we're basically going to expand this using our identity, and it's going to simplify down into, sine. So this is your x, this is your y, cosine of x, cosine of 3 pi over 2. This is plus, but in our identity we need to write minus. Subtract sine of x, sine of 3 pi over 2. You know the ones with 3 pi's over 2, so we're going to replace them. So this is going to be cosine of x times 0 minus sine of x times negative 1. It simplifies down. This next one is not totally the easiest thing in the world. And that's only because you have kind of a complicated expression going on over here. So we're going to call this whole thing your x, and then this whole thing is your y. It's cosine again, so we're going to say cosine of pi over 2 minus x, cosine of y. We're subtracting, so change it to plus, sine of pi over 2 minus x, sine of y. From here, what we have to do is we have to expand a second time with these guys. So the second expansion is going to be cosine of pi over 2 cosine of x. We're subtracting, so we would say plus sine of pi over 2 sine of x, all of that multiplied by cosine of y, plus, expand that guy, sine of pi over 2 cosine of x, subtract cosine of pi over 2 sine of x, all multiplied by sine of y. Cosine of pi over 2 is 0, that's going to go away. Sine of pi over 2 is 1. Sine of pi over 2 is 1. Cosine goes away. So let's clean this guy up as best as we can. This turns into cosine of x plus sine of x times cosine of y plus cosine of x, that's a 0, so that goes away, times sine of y. Let me double check that. Sorry, I messed this guy. This was 0 times cosine of x, so this goes away as well. Let's take that guy away, and it's just going to be that. So now I have sine of x cosine of y plus cosine of x sine of y. Hopefully that looks a little familiar to you, because that's actually the identity for adding, subtracting sine. That one's not as easy, but what we did is a double expansion. So we expanded, we treated this guy as just x when we did our first expansion, and the double part was when we looked at these two pieces and we expanded those as well.